All right, so let's take a look. So we rewrote using our properties. So the subtraction means we have division, right? Oops, I'm not in highlighter mode. So the subtraction here means we have division here, and then log base 2 of something equals log base 2 of something. I set those equal to each other. We're going to cross multiply and then solve. Now we do need to check. We do need to remember to check any of these answers to make sure that they are going to be okay and that we don't get a negative argument. Remember, none of the expressions here that are the main part of the log can be forced to be something negative. So you do want to check for that. And we'll see a couple of examples of that here in a minute. Okay. All right, we need to simplify this. So how is that going to get simplified? Jack, how is that going to get simplified?
5.
Yep, we're jumping down to 5. We're not doing number 4.
Log base, or 2 log, what would be log base x squared minus 3x, which would be,
There you go. Yep. Okay, so log of x squared minus 3x, once we've distributed, right? We've multiplied the x times the x minus 3, and then that's equal to log of 28. So then similarly here, log of some amount equals log of this amount, and so that's what we're going to focus our attention on. That's what it has to be equal to. So x squared minus 3x equals 28, and that's what we're going to solve. This is quadratic, so 0 factor solve. This is similar to one I think we saw yesterday, isn't it? Okay, so if we go back and check these, if we plug 7 in to either of this, to here or here, we're still going to be positive, so we're okay with that. But if we plug -4 in here, we would have a negative argument. So what that's telling us is that we cannot include that as a solution.
Will you look into the original problem?
Always look to the original, yes. Now, please be careful. I think the tendency is if you see that you get a negative solution, that you assume that it's not going to be a solution. And it may or may not be. I also want you to realize, though, some positive solutions might not work either, right? If we looked at this, regardless of what this answer is here, but just look at this particular, if we had to plug in, if we were told that, as an example, that x is equal to 1 was our solution, if we plugged into this, we would get something negative. That would be a problem, so x equals 1 would not work, right? Does that make sense? So don't just assume you have to check all of your negative answers. You need to check your positive answers also. Okay, let's do this one, because this one's actually a little bit different. Because of that extra number in there, that kind of adjusts things a little bit. So we actually need to move this over to the other side. So we're going to think of this as log of 3x minus 4, and then minus that log equals 1. Okay, now we can simplify. So Jackson, what do we get when we simplify this and condense that to a single log?
log,
What does the subtraction mean? What operation are we going to do? Divide. There you go. So the 3x minus 4 is positive, so that means it's on top.
yeah, and then over 2x plus 3.
There you go. Good. You got it. It looks weird, so I think you were probably a little bit hesitant there just because it just does look a little bit weird, but that's exactly right. All right, now we are gonna have to solve this a little bit differently. This is what we're gonna focus our attention on most of the next page. We have a logarithmic equation. To solve, think about what the inverse operation is. The inverse operation of logarithms is exponents, right? So if we're going to do the inverse operation, it means we need to rewrite this so that we're writing it in exponential form. So first thing we need to think about is, what's our base understood to be here? 10, yes. So remember, our base is understood to be 10. If we're going to rewrite this using exponents, two different ways to think about this that you guys I showed you to think about this. The one, if you're a visual person, we drew an E, right? And so we started at the 10, the base, and then we went to out here, and then this particular number. So we drew an E. So what that's telling us is that we have 10 to the first power is equal to this funky fraction that we got, that Jackson helped us with. Others of you I know remember it by doing first, last, middle. So here's the first number you come across, here's the last number you come across, here's the middle expression that you get to, all right? Either way you kind of want to think through that, all right? Okay, so now we need to cross multiply and solve here. So we get 20x plus 30, 3x minus 4, whoops. All right, Ireland, sneak a 0 in there. 20x minus 3 is 17x negative 34. So for x, we get negative 2. So let's go back and check. Is that going to work if we plug negative 2 into this? No, we're going to get negative answers. So on this one, it means we've got no solution. Okay, that's a little light, sorry, let me make that a little darker.
Wait, how do you know it's no solution?
Because the one answer that we did get when we were solving does not go back and check up here. Imani, if we plug negative, what was it, negative 2 into this argument, we're going to get a negative argument, and we can't have that. Okay, good question, glad you're asking.
Are you plugging it into the very original equation?
Yes,
Okay.
you always want to plug into the original. All right, onward, and like I said, we're not going to do all of these, but we're going to do a few of them. Okay, on these, this is going to kind of be the basic general form of most logarithmic equations, and that is, if we are given a logarithmic equation, remember the inverse, to solve equations, we think of the inverse operation. And the inverse operation, if we are dealing with logarithms, is exponents, right? So in other words, rewrite using exponents. So make that note if you feel like you need to. And that's where the E comes from. Not entirely, but you get the general idea. Okay. Notice what the directions are saying. In this case here, the directions are saying round to the nearest hundredth. Sometimes the directions may say leave in exact form, and I'll kind of show you where that falls in some of these problems in just a second. Okay? All right. In this first example, I want you to think about the fact that using our properties, the initial way this could have been written would have been as ln x squared, right? So the first step we could have or would have done would be drop that 2 out in front, because properties tell us we're allowed to do that. So that moves the 2 from exponents into the numerator. But then now the beauty of this is that we can just divide by that. So ultimately, we want to get that logarithmic expression just strictly by itself. So we get ln of x is equal to 9. And then we need to rewrite this using exponents. What is the base understood to be? Uh-oh. Yeah, remember ln is the same thing as writing log base e, right? So log base e of x is equal to 9. Good. Okay, so when we rewrite this, then we're going to rewrite this using exponents as e to the 9th is equal to x. That is what I would refer to as the exact answer, right? And then if I asked for the approximate answer, then you would just plug into your calculator. So make sure you get comfortable with where your ln key and your e keys are on your calculator. So that is approximately 8103.08. Okay, so you guys are going to help me with these next ones. Comments or questions before we look at some of these others? Okay. All right. Taylor, what do you think we should do first on this one? What are your thoughts?
Just subtract the 7 from the 3 and then move it over to the x.
Okay, yeah, there you go. Let's subtract the 7. And so that leaves us with -3 log of 10x. That doesn't have parentheses, but you could put those there just because it is kind of a quantity. All right. Okay, then what? What do you think, Alex?
Down to, move, the 3 to the x, like, -1. I don't know.
We could move it to the exponent, but what did we do over here? To kind of clean things up even. Yeah, let's divide by that -3. So then that gives us log of 10x is equal to -2. All right, if we want to rewrite this using exponents, and I'm going to put that little base in there to help us remember. If we're going to rewrite that using exponents, what is that going to become? Lily?
Would do 10 negative 2 equals x.
There you go, 10 to the -2, careful, equals 10x. I don't know if I heard, I didn't hear you say the 10x. You may have, but, okay. Couple of ways to deal with this because of this negative exponent. If you've got your calculator and you're allowed to use it, then convert it to a decimal. But 10 to the -2 as a fraction is just 1 over 100. And then that's equal to 10x. So guys, when I see fractions, I don't want to think of it as dividing by 10. I want to think of it as let's multiply by 1/10. So then we get that x is equal to 1 over 1,000. Okay. All right, questions or comments on that one? Okay, we're jumping down to number 10. Ariana, let's rewrite that using exponents. How are we going to do that? What's it going to be? Draw your E or think of your first, last, middle. The 2x minus 2 actually becomes what it's equal to. So that's the last little bit. What do we do with the 3 and the 4? Which one's the base?
3.
Okay, so we need the 3 as the base. So what's the 4?
Exponent.
The exponent, yep. So 3 to the 4th is equal to 2x minus 2. So, all right. So 3 to the 4th we know is 81. And let's go through and add. I'm going to do this in kind of in one step. So it's going to be 41.5. Okay. All right. right. And then, all right, questions on that? I'm kind of, I want you guys to have a little bit of time if possible to work on this so that if you have questions, you can. But I've got two more we're gonna look at here real quick. Okay, let's rewrite using exponents. Piper, what are we gonna get when we rewrite this using exponents?
-1 to the 2 is equal to 7 minus 2.
Okay, let's switch that order. This is our base, so that's kind of what we start with. So 8 to the -1 is equal to that 7 minus 2x. This one, once again, you end up with these fractions, so it's kind of personal preference how you deal with that. If you've got your graphing calculator and are allowed to use it, just go with the decimal form of it. For me, I'm dealing with fractions personally. I would rather do that. Although combining a -7 and a +1/8, I want to think of this -7 as, 8 times 7 is 56 over 8. So this here is equivalent to that -7, just so that I have my common denominator to combine. Okay, do you see that? The -56 over 8 is equivalent to the subtracting of the 7, so that I can combine, I have my like terms there. All right, and then once again, I would rather think of this as multiplying by a -1/2 rather than dividing by 2. And so we get that x is 55 over 16. If you're doing decimals, it's 3.4375. And by the way, I've not been mentioning this, and maybe I should, go back and check. This 41.5 is okay if we plug in. This 3.4 is gonna give us, it's gonna be okay. We're not gonna end up with a negative answer, I don't think. We should be checking that. Okay, last one. This one involves a little bit with properties. Catherine, what are we gonna get when we simplify that first?
You have to divide it, right?
Yep, the subtraction means division. Good. So what's gonna go in the numerator? What do you think?
Or the exponent?
Yep, we do want to have that. Yeah, we want to have that exponent. We got to do with the 2. I think that's what you're referring to, is we got to do with this 2 too, don't we? So yeah, we can change that and make that our exponent. So x squared, and then what's in the denominator?
9.
Careful. Well, 9 is our base. What's getting subtracted? What number?
3.
There you go. So we need the 3 there, all right? Okay, so log base 9 of x squared over 3. Now we've simplified. Now we've got the log by itself, so we can rewrite using exponents. So Aiden, what do we get when we rewrite using exponents there?
9 squared
Mm-hmm.
equals x squared
Over 3. Okay. So 9 squared is 81. 81 times 3 is 243. And so x is approximately, I have this written down somewhere here, 15.59.